Hello everybody. This is Unit 3, Day 1. All right. Excuse me. So, let's get started here, okay? So, I said I would do the video anyway, right? Just if you guys were confused from class, you guys will have an opportunity to go back and watch this, okay? So, Unit 3, Day 1. So, the definition of a quadratic is a polynomial whose highest exponent is 2, right? Or we could say highest degree of 2, okay? So what do I mean by that? Well, our parent function for a quadratic is just simply y equals x squared, right? All right, now we've seen problems that have extra in the back, right? X squared plus 2x minus plus 3, all right? Something like that, okay? Which is, this one is also factorable, but anyway, no it's not. I take that back. So, regardless, all right? This is what we call standard form, okay? As you can see, our degree measure goes from lowest, or from highest to lowest, right? So, degree measure here, well, that is 2. Degree measure here, well, that's 1. Okay, whoops. 1. Well, let me write it there. All right, and then our degree here is just 0. All right, and so what do I mean by all that? We're just looking at their exponents, right, associated with the x variables. All right, and in this case, all right, when we're talking about quadratics, the highest you see as far as degree measure or exponents is to the second power, okay? Anything higher would be something completely different, okay? All right, so the definition of the axis of symmetry. Well, that's the vertical line that passes through the vertex okay, and so what does that mean? Well, here is a x and y graph, coordinate plane. Here is our quadratic. Don't forget they can also look like this. Okay, they can go the opposite direction, but in both cases, okay, the vertex, if you recall, is what we call your turning point, right? It's the spot where it either stops decreasing and starts increasing, or vice versa. It's where your graph changes direction. All right, and so your axis of symmetry is actually your vertical line that kind of cuts your quadratic in half. More importantly, it creates a symmetrical image on either side of that line. Okay, so that's why it's called the axis of symmetry, because it's not cutting it, you know, anywhere else but directly in the middle of your function. All right, and also, we got to remember this is a Vux line, right? So it's always going to start with a x equals. All right. So that being said, x equals what? Well, in order to find that axis of symmetry, you need this formula, negative b over 2a. All right, so I'll talk about where those letters come from. All right, your definition of the vertex, all right, is found right here. So if you find your axis of symmetry, you take this value, plug it back into your function, and it'll give you whatever your y value is when that x value is equal to whatever you have there. Okay, so formula for axis of symmetry is this. The definition of a vertex, right, is the turning point of your parabola. And the definition of roots is just your x-intercepts. Okay? So I'll go through this part in class when you guys see me. All right, this involves calculating steps for finding roots using your calculator. All right, but we are going to find them in other ways. All right? More important, we're just going to do the grunt work. So the graph of a quadratic function. All right, so remember, this is standard form right here. Okay, which means, again, we go from highest degree to lowest, right? And then as you can see, we got an A, B, and C, which these are the values that fall either before your x variable, or your C is just your constant that falls at the end. Okay, so in this case right here, right, we have y equals 2x squared minus 8x plus 5. So it asks us for the vertex. Okay, so in order to find that, I must first find the axis of symmetry. So our axis of symmetry is equal to negative b over 2a. So we go up here, right, our b value is a negative 8, and then our a value is just a 2. So I get 8 over 4, which is equal to 2. So our axis of symmetry is the vertical line x equals 2. And let me draw that in right now. Okay, x equals 2. All right, now let's find the vertex. So I'm going to take this value. I'm going to put it anywhere I see an x. Okay, so again, remember our vertex is just that x value with the y value. All right, so we're going to go 2 times 2 squared minus 8 times 2 plus 5. And so I get 2 squared, which is 4. 4 times 2 is 8. Minus 16 plus 5. So we get a negative 8 plus 5, which is a negative 3. So our vertex, which I'm going to put in purple, is going to be 2, comma, negative 3. Right, again, as you can see, where I go to graph this point, it falls directly on that axis of symmetry line. And then when I do finally graph this thing, you'll see that that is our turning point for our graph. Now, it's asking for find the roots to the nearest hundredth. Okay, so unfortunately, because I can't show you on the calculator here, we're going to have to use the quadratic formula. Okay, and again, what does a quadratic formula do? All it does is it finds your roots. It finds your x-intercepts. Okay, so let's write that down. So x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's take a look at what these values are. Well, b is a negative 8, so I go negative 8 plus or minus, all right, b squared, so it's going to be negative 8 squared minus 4 times 2 times 5 all over 2 times 2. Okay, so my suggestion before you just go plugging away here, find out what the value is inside your square root. All right, so we go negative 8 squared is going to be 64 minus 4 times 2 times 5, which you get 8 plus or minus square root 24 all over 4. And I guess I can simplify that even further. No, I can. Okay, so we're good there. All right, that being said, all right, notice we have this plus or minus right here, which means our answers are going to be x is equal to 8 plus square root of 24 divided by 4, and x is equal to 8 minus the square root of 24 divided by 4. Okay, remember when you're solving quadratics, we're getting two answers. So x is going to be finally equal to 3, and it says round to the nearest hundredth, so 3.22. And over here it's going to be 8 minus square root 24, 0.778. Okay, so now, what did we just find? Well, these are our roots, right? Again, we use the quadratic, so this is where our graph crosses the x-axis. So x is equal to 3.22, and x is equal to 0.78. All right, and then finally, our y-intercept. Well, our y-intercept is when x is equal to 0. So when I take it as 0 and I plug it in for all my values of x's, we're left with just a 5, right? Because 5 is the only one that doesn't have an x next to it. And so that is how I came up with my y-intercept so quickly. So 1, 2, 3, 4, 5. Okay, there's a point. All right, I got a couple other points here. Okay. Finally, I got enough to kind of sketch this graph here. We got 4 points on there. And so there is our graph, right? Or at least a sketch of it. It says circle the roots and label them. Okay, you got it. Roots. Roots. All right. What else we got on this sheet here? Oh, okay. Over what interval is the graph, or over what interval of the domain is the graph increasing and decreasing? Okay, so in both cases, it's going to involve our vertex. Again, remember the vertex is the turning point, right? So where are we increasing from? Well, it looks like we start at 2, right? So we start at 2 and we're increasing as we approach infinity. Again, this is going to the right and up forever. And where is it decreasing from? Well, same thing, except it's just going to be switched around. So it's decreasing as x approaches from the left. It's starting from negative infinity, and it's stopping, decreasing at 2. Okay? So that's how I came up with those. For what intervals of the domain is y greater than 0? So again, we're looking at when we are below the x-axis here, right? And so when are we below those? Well, it's going to involve our roots, right? When our graph crosses the x-intercept. So where's y greater than 0? Well, when x comes from negative infinity all the way up till when it hits 0.78. And again, this is not y is greater than or equal to, so we want to make sure that we use parentheses instead of brackets. And then where is it above 0 again? Where is our graph above the x-intercept? Well, 3.22 all the way till positive infinity. Okay, so over what intervals of the domain is y less than 0? Right, it's when we are not below the x-intercept. Okay, and then over here, where is y is less than 0? Okay, well, it's still going to involve our roots, except we start at 7.78, and where are we still below the x-intercept? All the way up till 3.22. Oops, and I don't want that in brackets. I want that in parentheses. All right, and the last part, find the average rate of change. Okay, when we're talking about linear equations, this refers to as slope. Okay, now slope only involves linear functions, all right, but the process is still the same. Okay, in order to find the rate of change, we're going to need this formula right here. y2 minus y1 over x2 minus x1. Okay, so right here, these are domain values. So these are x values, right? Okay, so in order to use this, I got to figure out the rest of these points here. So my one point is -1 comma something, and the other point is 3 comma something. So in order to find out what my output is, all right, I'm going to use these values as kind of like my input, right? So when x is equal to -1, what is y equal to? Now I'm going to cheat, and I'm going to plug this into my y equals. All right, and so by doing so, at -1, we're getting a positive 15. And when x is equal to 3, we get a -1. Okay, so find the average rate of change. Well, we're going to use this formula right here. I'm going to go x1, y1, x2, y2. And so I go -1 minus 15 all over 3 minus -1. So on the top, I get -16. Down below, I get a positive 4. And -16 divided by 4 is a -4. All right, so our average rate of change is -4. Okay, let's move on to the next part. The vertex form, okay? So we will see this quite frequently throughout this unit, right? Vertex form will be coming up a bunch. So what does that look like? Well, it's y equals a, x minus h squared plus k. All right, and so the reason why they call it vertex form is because, well, it gives you the vertex, right? So let's talk about that. Our vertex, in this case, is h comma k. All right, now we got to keep in mind, all right, that the formula calls for a negative sign. It asks for a negative sign in between the x and the h, okay? So you have to account for that when you're coming up with your vertex, right? So when I look at this, I'm looking at these values right here. All right, so I already see a negative sign there, so it means my vertex is just going to be 1, comma 3. All right, now if this was, for whatever reason, if this was a plus 1, all right, well then we'd have to take into account, okay, well this is 2 times x minus -1 plus 3. Okay, so what is our vertex here? Well, our vertex wouldn't be 1 comma 3, it would actually be -1 comma 3. Okay, so just keep that in mind. All right, pay attention to that negative sign in between the x and the h, because that will throw you off if you don't know where that is coming from. Okay, so let's keep going. All right, the axis of symmetry. All right, in order to find that, we need the negative b over 2a. All right, well, I could essentially, multiply that out and try to find all that stuff, right? But what's nice about vertex form is we don't have to use this formula anymore. It already gives us our vertex, right? So we just need to account for, well, what's our x value? It's just a 1. Okay, so our axis of symmetry is just x equals 1. All right? Now, let's get to x-intercepts and y-intercepts, okay? Now, if you were to graph this thing, right, if you were to graph this thing, you would see it would look something like this, okay? So it's crossing the x-axis, 0, comma 5. Okay, 1, comma 3. 2, comma 5. What in the world? Well, that's not right. Hold on a second. Oh, right. Okay. Oh, I had it backwards. I'm sorry. 0 is 3. 2 is 5. Whoops. There we go. 3 is 11. Okay, so it's going to be up here somewhere. All right, and so our graph is going to look something like this. All right, so what it's asking, all right, is do we have any points? All right, if you looked in your... So what I did here, guys, take this and put this into your y equals. All right, and go to your table, right? Get those values on how to graph these things, right? Because I don't, based off of this right here, I don't know what to graph, right? So plug that in, find your table of values. All right, now, once I've done so, you'll see, right, never once does our y value equal 0. Our lowest y value is actually right here. All right, so that's kind of like our minimum, right? And so our x-intercepts, well, there is none. Okay, sometimes you don't have that. Sometimes you won't have a solution, right? And so in this case, we don't, right? We don't have any x-intercepts. We do have a y-intercept, though. That is 0, comma 5, okay? And again, I got that directly by plugging this into my xy, right? So -1, we're at 11, 0, we're at 5, 1, we're at 3, 2, we're at 5, and 3, we're right back to 11. Okay, and so that's how I came up with those. Circle our roots. Well, There is none, right? So we can't do nothing. No roots to circle. Over what interval is the domain? Over what interval of the domain is the graph increasing? Well, that's going to involve our axis of symmetry. So it's increasing from 1 to infinity. And it's decreasing from, negative infinity to 1. Over what interval is the domain greater than 0? Or y is greater than 0? Well, that's for all values, right? Or in this case, we could say all real numbers. That's what that stands for, all real numbers. Okay, where is it less than 0? Well, we call that the empty set, right? Right, because we don't have any values that fall below our x-axis. And find the average rate of change. All right, so I go back to my table of values. All right, so in order to find the average rate of change, y2 minus y1, x2 minus x1. Okay, so -1, we're at 11. At 3, we're also at 11. All right, so I'm going to go x1, y1, x2, y2. So we go 11 minus 11 over 3 minus -1. And what do we get? 0 over 4, which is just 0. Right, so let's think about that, though. Why does that make sense? Well, what we just found, all right, so at -1, we're somewhere up here. And again, at 3, we're somewhere up here. Right? So what happened is, when we found the average rate of change, we found the rate of change coming down, and then we also found the rate of change coming back up. And what happens is, because those lie directly across from each other, right, horizontally, our rate of change cancels out. Okay, so if you're wondering why that's a 0 there, it's because if you look on our graph, all right, our y values are the same there. So our average rate of change actually cancels it out. Okay, root or intercept form of quadratic equation. And this is the last part. Okay, so the form looks like this. Okay. To graph this thing, again, I'm going to have to plug this into my x and y. All right, so I'm going to do that right now. Make sure to change those t's to x's. Okay, so I'm going to go, -3, 5, -2, 8, -1, 9, 0, 8, 1, 5, 2, 0, and I want to put this last point in here, -4, 0. Okay? I'll explain why I'm adding that point in there. All right, so let's graph this guy. So -4, 0, -3, 5. Where are we at here? -3. Whoops. Got to go back one more. -4, 0, -3, 5, -2, 8, 1, 9, back down here. Okay, and there is the picture of our function. Okay, so last part, let's talk about the vertex. Well, our vertex, as you can see, right, when is our highest point? Right, when is our turning point here? Our turning point happens on this line right here. Oops. Go back. This line. There we go. Okay, and what is that line? Well, that is the line of our x equals -1. Okay, so our axis of symmetry is just x equals -1. Our vertex, -1, 9. Our roots, right, are actually given here, right? Where's our roots at? Well, -4 and 2. Right, so it actually gives us our roots here. Let me put that in better form there. There we go. Okay, our y-intercept, well, I'm looking for when x is equal to 0. So there's 0, 8. Over what interval of the domain is the graph increasing? We would say -infinity all the way up till our axis of symmetry, which is -1. And we're decreasing from, -1 to infinity and beyond. All right, so over what interval is our domain greater than 0? Well, this involves our roots. So we're greater than 0 when from -4 all the way up till 2. And we're less than 0, -infinity to -4. Whoops, wanted these both in parentheses. And -4 all the way to infinity. All right, and we'll just skip this last one because we're running out of time here. All right, so anyway, this is everything from the lesson today. All right, if we didn't get there in your guys' class, then hopefully watch the video, and there's the rest of the problems, okay? So I know this was lengthy. I apologize. All right, try to grasp at least what it means to find your x-intercepts, y-intercepts, axis of symmetry vertex, okay? And then on Thursday, we will go through all these homework problems, okay? So watch the video, get comfortable with what it is I'm trying to talk about here, and then we will practice these things in class going through the next homework assignments, okay? So good luck, everybody.